Hi guys, and welcome to the second lesson. So in the first lesson we saw how to write the dynamic equation of this little car during the braking phase. We write the dynamic from the longitudinal axis, the vertical axis, and rotation about the center of gravity. In this lesson we talk about the longitudinal load transfer that will happen during the braking phase. Okay, so let's jump to a new spreadsheet. What we have here is just the three equations that we wrote and we saw before. So we have the first of this equation will be the longitudinal equation, okay, is the longitudinal motion, or the second will be the vertical dynamic equation, and the last one will be the rotation about the center of gravity of the car. To understand how the car behaves, let's consider some case. The first case that we can study from this equation will be when the velocity or the speed of the car u will be constant. Okay, if we have u constant, what we know is that u dot, the acceleration or the deceleration, will be equal to 0. Okay, so how this system change with this assumption? So we know that x1 plus x2 will be equal to 0. The second one equation will be exactly the same, so z1 plus z2 equals mg, and the last one will be the first, or this will be equal to 0. So we have z1 a1 will be equal to z2 a2. Okay, so let's solve now this simple system. From the third equation we know that z1 will be equal to z2 a2 a1. Okay, let's put this now consideration in the second equation, and what we have is will be z1, so z2 a2 a1 plus z2 will be equals to mg. Okay, so and that mean that z2 will be equals to we have a2 a1 plus 1 will be equals to mg. Okay, and this will be z2 will be equals to mg, and here what we have will be a1 plus a2 to a1. Okay, but in what we have here is just a1 plus a2. We know that a1 plus a2 will be equals to the wheelbase, so this equation will be will be mg a1 l. Okay, and if we put this now value on the other equation, this one, what we know is that z1 will be equals to mg a1 l a2 a1. We can now simplify and we obtain mg a2 l. Okay, so let's write again these two equation. One is this one and the other one is this one, and what we saw is Z2 will be equals to mg A1L, and Z1 will be equals to mg A2L. And these what they are is static load. So when the car is not decelerating or accelerating, we have a constant force. Let's call this one Z2 0 and Z2 1 0. Okay, they are static loads. Static loads on front and rear axle of the car, of course. And now we can use this static load to understand how the car behave during a general braking situation. Let's move just a little bit above. Okay, now we use the same equation that of course we obtained in the first lesson. Let's copy and paste to have some space, and let's consider another scenario. Okay, so okay, now that we know what the static load are from the front and rear axis, we try to study a general situation. So let's assume that we know the u dot. Okay, so for example, we have that u dot will be equals to an value. Okay, so will be a parameter. Okay, we know u dot. So what we can do from if we put the first equation in the last one, from this and this, we now write this equation. So we have minus mu dot h minus z1 a1 plus z2 a2 will be equals to 0. And now we can write from this equation, we can write z1 a1 will be equals to z2 a2 minus mu dot h. And now we have z1 equals to a2 a1 minus mu dot h a1. Okay, if we use the second equation, okay, we put now this equation on our first equation here. What we obtain will be let's write a little bit above, okay, below, and it will be z2 a2 a1 minus mu dot h a1 plus z2 minus mg will be equals to 0. and this will mean, okay, from this equation we can obtain zeta 2 1 plus a2 a1, okay, will be equals to mg plus mu dot h a1. Okay, and now what we have will be very simple. So we have zeta 2 a1 plus a2 a1. Here will be the same mg mu dot h a1. Here we have L as we did before, so this will be L. So we have zeta 2 will be equal to mg a1 L, okay, plus u dot HL. It is will be what we now know, okay. But in this equation what we can see is here we have what we call the static load, no? As we saw previously, we now know that zeta 1 and zeta 2 0, mg a1l and mg a2l will be the static load. So here what we have is the zeta 2 0, the static load on the rear axis of the car, okay, because as we saw in the previous lesson, we know that zeta 2 will be the static load on the rear axis of the car, zeta 1 will be the load on the front axis of the car. And here we saw that zeta 2 will be zeta 2 0 plus something, okay. And now we can obtain, of course, zeta 1, because zeta 1 we know that as we saw in this equation, okay, this is equation that tell us that zeta 1 plus zeta 2 will be always equals to mg. So now if we put together these two equations here, we can now write that zeta 1 plus mg a1 L plus mu dot H L will be equals mg, okay. Let's write what we can obtain from zeta 1. It's very simple to solve this equation, and now we have mg minus mg a1 L minus mu dot H on L. Here what we have is zeta 1 will be equals to mg 1 minus a1 L and now let's solve this little part. What we know is zeta 1 will be equals to mg a1 plus a2 minus I1 on L and U dot H on L, and of course we have Z1 will be equals to mg HU L minus mu dot H on L. Okay, and this is our second equation from this. Of course, this will be from the front axles of the car, and this one will be from the rear axis of the car. Okay, what we saw here will be exactly the same that we did before. So here we have Z1 0, the static load, and we have another term. Okay, let's compare Z2 with Z1, and what we see here is that the addendum term will be exactly the same. We have mu dot HL from Z2, and here we have mu dot HL. So we have exactly the same value, but the only difference between Z2 and Z1 will be on Z2 we have the plus sign, and on Z1 we have the minus sign. Okay, let's interpret the physics here. So what we know is very simple. Let's use the figure that we saw in the first lesson. So we have just to copy and paste here. So we use exactly the same figure. Let's copy and paste here. Let's move a little bit. Okay, now we can cancel this, and let's clean a little bit this figure. Now we know everything about the dimension and the center of gravity and other stuff. Okay, we remove x1 x1 x2 and x1, and we left only the vertical load. So this will be our car during the braking phase. Okay, so in the first part of this lesson we know the static load. So when the car is moving to a constant speed, let's assume that now the car is moving to a constant speed on this direction, on the right. So what we know is on front axis and on the rear axis we have Z2 0 and Z1 0, and as we saw before, this will be the value of the equation. So one is this one and the other one is this one. Let's write here. So we have Z1 0 will be equals to mg HU L, and Z2 0 will be equals to mg A1 L, where L will be, as we saw in the previous lesson, the wheelbase will be L, and the longitudinal distance from the center of gravity of the car and the rear axis will be HU, and the longitudinal distance between the center of gravity of the car and the front axis of the car will be A1. So as you can see, the vertical force will be changed according to the other dimensions. So on Z2 the rear axis of the car, we have A1, the longitudinal distance between the front axis of the car and the center of gravity, and for Z1 will be exactly the same consideration. We have A2, okay, and this force will be constant, okay. Each of these force will be constant. It will be directly proportional to the total mass of the car, the gravity acceleration, and A2 and A1 according to Z1 and Z2. Okay, let's see now what we can obtain from the second scenario. We need to copy and paste this figure. Let's remove a little bit this old equation, okay, and let's copy and paste the equation. So we have Z2 will be this one, okay, copy and paste. Let's move a little bit here. Z1 will be this one, copy and paste. Let's clean a little bit this equation. Okay, just clean a little bit. Okay, let's adjust now. So we have A1, H, MG, HO. Okay, let's move a little bit now the equation. We can now move all this equation. Okay, now what we know is that the car, if the car is moving on the right, we have of course a mu dot during the braking phase. Mu dot will be below zero, so will be negative, and what we know, we call this one as delta z. So delta z will be equals minus u dot h on L, and this what will be is the longitudinal load transfer of the car. So the longitudinal load transfer. Okay, so in this situation we know that Z2 will be equals to Z2 0 minus delta Z. Z1 will be equals to Z1 0 plus delta Z. Okay, of course, as we told before, mu dot will be negative, so delta z will be positive during the braking phase, and the opposite sign will be placed, of course, during the acceleration phase, when the car is accelerating. And now we can see here is a little bit changes of this figure. Let's adjust our figure. So we know now that during a general braking phase we have a force a little bit higher on the, as you can see here, we have Z1 0 plus delta Z, and delta Z will be positive. Z2 will be something a little bit below that than the static load force. So here we have a little so here we have to adjust our force, okay, because now we have during the braking phase, here we have Z2 and here we have something higher than Z2, okay? This is what we tell the physics. So a higher force on the front axis, here will be higher force, and here we have a force that will be a little bit below, okay, and this below will be M U dot H L. So the higher will be the center of gravity, and the higher will be the longitudinal load transfer. The distance between wheelbase, okay, the distance from the rear and front axis of the car will be lower the load transfer. So the higher will be L, the lower will be delta Z. And of course, if we have the acceleration during the braking will be higher will be the delta Z. The same will be to M, okay? And this complete our lesson. So in this lesson we saw what is the longitudinal, what is delta Z, okay? Delta Z will be our longitudinal load transfer, and we know now what are Z1 0 and Z2 0, and these are statics load, okay? And this completes our second lesson.